Okay, the next part of the process you may or may not have that much control over, but certain portions you do. In most simulation processes that we're going to talk about anyway, involve discretization. Basically, this is the process of taking your continuous model and turning it into a discrete set of algebraic equations. So the finite element model, finite volume model, and finite difference method, these all use different techniques, but they do all have one commonality, which is that at least in space, there's a mesh. There's like an XY, there are certain XYZ locations where the solution of the algebraic equation will be calculated. So that's called a mesh. That mesh is a user choice. How many of those points you use and where you put them is a user choice. If you make a bad choice, you won't get a good solution. So we'll talk a lot about that in the verification step. If you're integrating in time, if you're doing a simulation where a transient simulation, there'll often be discrete time steps involved too, which are often a user choice. And so choosing the correct time step is important in the discretization process, and actually choosing how to, typically when you're stepping forward in time, it's because the rate of change of your solution depends on something. So how you model the derivatives or that rate of change actually matters too. So there's choices like forward difference, backward difference, centered difference, upwinding in the case of CFD solutions and things like that. These are all user choices, and those user choices have consequences. The consequences of these things are often they affect the accuracy of the model, but accuracy may not be the only thing you care about. In fact, a lot of times, especially in CFD, you're often interested in stability. Can I actually even get the thing to converge and give me a solution? For large simulations, you're going to care about computer memory, and you're going to care about computer time, like how long it takes to actually get that solution. So you'll see for many CFD solutions, the amount of computational time it takes is measured in hundreds of hours of CPU hours. So you really need to balance the need for all four of those things, and sometimes accuracy isn't actually the one that wins.